Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring factoring out the greatest common factor. Let's look at an example. In example 1, it says determine the greatest common factor, or the GCF, for the polynomial given it right using the steps below. In step 1, they want us to write each term in expanded form. So here's what this means. If we have 3x squared, we could rewrite this as 3 times x times x. And for 15x, we could write 15 as 3 times 5 times x. Then it says to highlight or circle the greatest common factor of the two terms. So each term has a 3 in common, so I'll highlight that. And then each term has an x in common. So to get the GCF, you simply take the things they have in common. In this case, it's 3 and x, and you multiply them together. So our greatest common factor of 3x squared plus 15x is 3x. All right, now in example 2, it says, for each polynomial below, identify the greatest common factor if one exists. So in problem A, we have 12x cubed and 18x. So what I'm going to do is I'm going to prime factor 12x cubed. Now when I prime factor, I always start with the smallest prime number, 2. And I know that 2 will go into 12 6 times. So I'm going to write the 2 down. So remember we said it goes in 6 times. So now I'm going to prime factor 6. And 6 could be rewritten as 2 times 3. So if I multiply that all together, 2 times 2 is 4, 4 times 3, I get 12. So I've prime factored 12. Now for x cubed, to write in expanded form, we just write x times x times x. Now we're going to do the same thing with 18x. We're going to prime factor it. So for 18, if I always start with 2. I try 2 first. I can factor 2 will go into 18 9 times. So now I'm going to try to prime factor 9. Well, 2 won't go into 9 evenly, so I'm going to try 3. And I know that 9 can be rewritten as 3 times 3. So the prime factorization of 18 is 2 times 3 times 3, because 2 times 3 is 6, and 6 times 3 is 18. And then I have just one x. All right. Now what I'm going to do is I'm going to highlight the things they have in common. So they each have a 2, and they each have a 3, and they each have an x. So to get my greatest common factor, I'm going to multiply all of those together. We have 2 times 3 times x. So the greatest common factor here would be 6x. That's the greatest common factor of 12x cubed and 18x. All right, let's look at 5x to the 4th power and 25x squared and try to find the greatest common factor. So I'll take each term, 5x4, and I want to prime factor it. Now remember I said I always start with 2, but 2 won't go into 5 evenly. 3 won't go into 5 evenly, and my next prime number is 5. So 5 will go into 5, and then x to the 4th would be x times x times x times x. Now 25x squared is going to be 5 times 5 times x times x. Now I'll take my highlighter, but you could circle these. It really doesn't matter. I'm just using the highlighter so you can see it a little bit better. I have a 5 in common with this 5. And then this x could be in common with this x. This x could be in common with this x. So for my GCF, I'm going to have 5 times x, which gives me a greatest common factor of 5x squared. So the greatest common factor of 5x to the 4th power and 25x to the 2 power is 5x squared. All right. Problem C, we have 12ab to the 3rd power and 20b squared. So let me start with the 12ab cubed. We already said in our example A how to prime factor 12 was 2 times 2 times 3, and then I have an A and 1, 2, 3 B's. and then we have 20b squared. So 20 is 2 times 10, and 10 is 2 times 5, and then we have a b times a b. All right, let me grab my highlighter here. I have a 2 in common. I have another 2 in common. Let me see. I don't have any a's in common, but I have a b here and b here. So our GCF will be 2 times 2 times b times b. So the greatest common factor of 12ab cubed and 20b squared is 4b squared. All right. Now in problem D, we have 3 terms. So we'll take 8x to the 4. And 8 would be 2 times 4, and 4 is 2 times 2. And then 1, 2, 3, 4 x's. 40x cubed would be 2 times 20. And we know 20 was 2 times 2 times 5. And then 3 x's. Okay. 24x squared. So 24 is 2 times 12, and we know 12 was 2 times 2 times 3, and then x times x. All right, let's see what we've got in common here. So 2, 2, 2, 2, 2, 2. I think we can go one more time. And then let me change to a different color for my x's. X, 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 and that's as far as we can go on the x's. So my GCF of these 3 terms would be 2 times 2 times 2 times x times x. And 2 times 2 is 4, 4 times 2 is 8, and then x squared. So 8x squared is the largest number that'll go into all 3 of those terms evenly. In other words, I could divide each term by 8x squared, and it would divide in evenly. All right. Now, could we make this shorter? Sure. Let's say we had 28. Let me erase that. I'm going to do this one a little different. We had 28w squared and 35w cubed and 14w. I want to know, let's just look at the coefficients first, 28, 35, and 14. I want to know what's the largest number that will go into 28, 35, and 14. So to figure that out, I start with the smallest number, 14, and I say 14 will go into 14. Will 14 go into 28? Yes. Will 14 go into 35? No. So 14 cannot be the greatest common factor. It's got to be smaller, something smaller than 14. So 14 is 2 times 7. So let's try 7. Will 7 go into 14? Yes. Will 7 go into 28? Yes. Will 7 go into 35? Yes. So I know the GCF of my coefficients is 7. Now, for the variables, that's the easy part. You just pick the smallest power. So in this case, I had a w to the power of 2, w to the power of 3, and w to the power of 1. So it would just be 7w. So the greatest common factor here is 7w. All right, let's try the next one. We have 12x to the 4th power, 24x to the 5 power, and 30x to the 3 power. All right, so I'm going to start by looking at my coefficients. We have 12, 24, and 30. So start with the smallest one. 12 will go into 12. Will 12 go into 24? Yes. Will 12 go into 30 evenly? No. So 12 cannot be our greatest common factor. So 12 could be rewritten as 2 times 6. So let's see if 6 will go into all of those. Will 6 go into 12? Yes. Will 6 go into 24? Yes. And will 6 go into 30? Yes. So our GCF for the coefficients is 6. Then for the variables, you look for the smallest power. So we have x to the 4, x to the 5, and x to the 3. So we go with the smallest one, 6x cubed. Now, we're going to be doing a process today called factoring out the greatest common factor. So to factor an expression, Let's talk about the definition of that. Factoring an algebraic expression is the process of breaking down an expression into a product of simpler expressions known as factors. For example, the expression 3x plus 12 could be rewritten as 3 times the quantity x plus 4. 3x plus 12 and 3 times the quantity x plus 4 are equivalent expressions. So our factors are 3 and x plus 4. So you're breaking an expression down into a product, all right? And each part of the product is known as a factor. Now, there's 3 steps when factoring out a greatest common factor from an algebraic expression. Step 1, you want to identify the GCF of the polynomial if it exists. Sometimes you'll get an expression that doesn't have a greatest common factor, all right? Step 2, you're going to divide each term by that greatest common factor. And then step 3, you will rewrite the polynomial as a product of the GCF and the quotient from step 2. Now, that sounds a little confusing, but you'll see what I mean by that here in just a minute. So in example 3, it says, write each polynomial below as a factored expression involving the greatest common factor of the polynomial. So in problem A, we have 30a squared b minus 5ab. So I want to look at my coefficients first. I have a coefficient of 30 and a coefficient of 5. I want the largest number that will go into both of those. So 5 will go into 5 and 5 will go into 30. So I know the numerical part of my greatest common factor is 5. Now for the a's, I want the smallest a. So that would be a to the 1 power. And then for the b's, I want the smallest power b, which that is just b to the 1 power. So my greatest common factor is 5ab. Okay, step 2 says you're going to divide each term by that greatest common factor. So that means I'm going to divide this expression by 5ab and divide this expression by 5ab. So my first term, we have 30 divided by 5 gives us 6. A squared divided by a gives us a. And b divided by b divides to 1. So 30a squared b divided by 5ab is just 6a. All right. Now over here, my second term, 5 divided by 5 is 1. Let's see, that divides to 1. A divided by a, that divides to 1. And b divided by b, that divides to 1. So that whole expression divides to 1. So 6a minus 1. Now, for my factored form, you write your GCF, which is 5ab, parentheses 6a minus 1. And then you write your quotient in parentheses. Now, if I were to multiply that back out, 5ab times 6a, I should get 30a squared b. And then 5ab times negative 1 should be negative 5ab. And sure enough, it does. So you can check these to make sure that you factored it correctly. All right. All right, problem B, negative 10x plus 30. Now, I need the greatest number that will go into 10 and 30. Well, hopefully you said it was 10. Now, I'm going to do a little something different this time. Whenever our first term is negative, we always want to divide out that negative. This will be important for later. So I'm going to say my greatest common factor is negative 10. And then they do not share an x in common. So my GCF here is just negative 10. So I know my factored form is going to look like this. Negative 10 times something. Okay. To get the quotient, you just divide each term by negative 10. So negative 10 divided by negative 10 is positive 1. And then we have x, so that would just be x. And 30 divided by negative 10 is negative 3. So this would be minus 3. Now you can check it. You can multiply it back out. Negative 10 times x is negative 10x. Negative 10 times negative 3 is positive 30. So it checks out. All right, problem C. Negative 6x cubed plus 12x squared. All right, our first term is negative again. So I'm going to say the largest number that will go into negative 6x cubed and 12x squared would be negative 6. And then for the variables, you take the smaller one. So that would be x squared. So I know in factored form, it's going to look something like this. Negative 6x squared parentheses something. All right, to get the quotient, I'll divide these by negative 6x squared. So negative 6 divided by negative 6 is positive 1, and x cubed divided by x squared is x. Here, 12 divided by negative 6 is negative 2, and x squared divided by x squared is positive 1. So our quotient would simply be x minus 2. So negative 6x cubed plus 12x squared could be rewritten as negative 6x squared times the quantity x minus 2. Now, in our next problem, we have 3 terms. So I want to figure out the largest number that'll go into 14, 35, and 7. So I know 7 will go into all 3 terms. And then you want to pick the smallest power. So we have x cubed, x squared, and x. So our smallest power is x. So I know we're going to have 7x times something. So to get the quotient, I'll just divide each term by 7x. All right, 14 divided by 7 is 2. X cubed divided by x is x squared. Negative 35 divided by 7 is negative 5. And x squared divided by x is x. Here, negative 7 divided by 7 is negative 1. And x divided by x is 1. So my quotient would be 2x squared minus 5x minus 1. All right, pause the video and try problem E on your own. All right, welcome back. Let's see how you did. I said that the only greatest common factor we had here was 2. All right, so I know my factored expression is going to look like this. To get the quotient, I'm going to divide each term by 2. So 2 divided by 2 is 1, and that would be, just leave me a squared. Negative 12 divided by 2 is negative 6ab. And here 6 divided by 2 is 3b squared. So 2 times the quantity a squared minus 6ab plus 3b squared. All right. Problem F, 25x squared, x cubed minus 40x squared plus 10x. Pause the video and try this problem on your own. All right, welcome back. I said that my greatest common factor here was 5x. And then I divided each term by 5x. So this gave me 5x squared minus 8x plus 2. Now, if you missed either part of the last 2 problems, pause the video now and correct any mistakes you might have made before we move on to the next part. All right, example 4. Rewrite each of the following expressions as the product of 2 binomials by factoring out a common binomial factor. Now, before we do this, I want to review something with you. You know, or you've learned that anything divided by itself is 1. So 4 divided by 4 is 1. 4x divided by 4x is also 1. In this particular problem, you're going to have expressions like this. X plus 4 divided by x plus 4. But again, anything divided by itself is always equal to 1. So I want you to keep that in mind when we are working these next 2 problems, all right? Now, these problems look harder than the ones you were doing above, but they're really not. So let's look at A. We have 5x times the quantity 3x plus 1 minus 2 times the quantity 3x plus 1. So what we have is we have an expression here and an expression here. And what I want you to notice that the greatest common factor here is a binomial. And that binomial, they both have in common, is 3x plus 1. So what I'm going to do is I'm going to divide, well, before I do anything else, I'm going to write that common factor down right here. Okay? I'm going to divide each term by the greatest common factor, which was 3x plus 1. Now, we said that anything divided by itself is 1. So this expression divided by this expression divides to 1 and leaves me 5x. And then on the right side, this expression divided by this expression is 1, and that leaves me minus 2. So our binomial is 5x minus 2. So our factored form is 3x plus 1 times the quantity 5x minus 2. All right, look at problem B. We have 2x times the quantity 4x minus 3 plus 5 times the quantity 4x minus 3. So our GCF here is a binomial 4x minus 3. So I'm going to write that down right here, 4x minus 3. And now I'm going to divide each term by that binomial. So again, 4x minus 3 divided by 4x minus 3 equals 1. So that just leaves me 2x. And over here, 4x minus 3 divided by 4x minus 3 is equal to 1. And so that leaves me plus 5. So my quotient was 2x plus 5. And that concludes today's lesson, factoring out the greatest common factor.